Hi everyone, this is George Williams from Lifeman Productions Squared, and today we are here to begin our 20th developers vlog. It's been quite a while since I've done any releases on the progress for the game, and this is going to be the start of a few videos kind of documenting progression over time of some of these various things. So I will try not to spend too much time. I know that these tend to go on pretty long, but I'm going to try and limit myself to about an hour and a half to 2 hours per day talking about stuff. So at most that, but probably less than that. So today we're going to go over pretty much everything, just kind of show you where the base level things are at so you can compare them to the next series of videos. Obviously this is on Monday, October 16th, 2017 is when we're doing this video, so be able to see how things go over the next 3 months. By the time you're watching this, it'll be January of 2018 sometime. I just want to kind of start there. There's been a very long drought in information about the game in terms of, what's been going on with it, and partially that's my fault, and partially it's just because, my fault isn't partially my fault for not, keeping the ModDB page up to date on what's going on, but also not really, kind of not my fault, but because of just other stuff that's been going on. I haven't had enough time to kind of get around to getting back into doing the updates and things like that. So what we'll be doing is instead of doing 3 months, 6 months, whatever it was I was doing before now, in terms of the update schedule time frame, we're going to be doing yearly updates now. Hopefully there won't be too many of them, maybe just 2 or 3. But yeah, we're going to be moving to yearly updates because this way I can get a lot more stuff done. The updates can be a lot more material heavy, if you will. They won't just be little tiny update things about like, oh, I changed this many lines of code, or I made this function do this or something, or some like 5 extra seconds of audio somewhere or something, and that just kind of gets annoying and old, and it also kind of hampers development because the way that I've been working on this game up until this point has been pretty much like, okay, I'll do a little bit here and there. Oh, I have an update coming. Now I got to cram it all into 1 week, and it just ended up being really crappy updates. So we're going to try and get away from that by really just kind of expanding out the time frame of the updates to 1 year and see how that works. That way, I have time that I can just kind of slack off if I want to, but then I also have time to actually work pretty intensely on it if I want to. And then by the end of it, probably have a fairly decent update a really bloody good update compared to what we were doing before, but fairly decent compared to what other sorts of projects like this do. So, that out of the way, let's go ahead and talk about the coding first. So, a lot of you have seen the other code here. I opened up in 2015, so don't mess around with that stuff. What is this? Recovered studio file. This don't recover. So a lot of you have probably seen. Some of you have probably seen this code. This is the old code from 0.6. You've probably seen me working on this in various parts of it in places, like, say, the database or something. Now, let's go over a little bit of history on this version of the game and the one preceding it. 0.5 build 5, I think. In between build 5, or rather as an evolution of build 5 to build 6 to version 0.0, 0.6, it's one of those days. I decided that I wanted to do some sort of system to allow modding to be done, period, on the game, to make it moddable, but also make it really easy to mod, so that it's not, and have a lot of depth in the modding, so that lots of things can be changed, lots of things can be added, so that you could almost make a full conversion mod on top of the base of the game, without having to access the code. Of course, full conversion meaning full conversion from this kind of game to a entirely different 4X game built on this platform that we have that has all the features that the game has. But some other game that just uses the exact same kind of functionality, features, and stuff like that. And over the course of 0.5 build 5 to 0.6, I decided that, okay, let's try and do that, and I'm going to try and figure out how to do that using INI files, or INI file and some sort of connection with the database. And so I looked up boost options for that. Well, boost, and then the thing in there is called boost options that had that functionality in it. So I started working on it with that, and then as I got more and more into that process, I realized that it was going to be really hard to deal with in some cases, just due to how the settings are being formatted in the INI file. Because there was kind of sort of like a repetition of some stuff, because you had to go to the database to find item ranges to define them in the INI file to properly have things load correctly, the way that you want them to. And so I decided that I was going to make a tool to do that. I started working on that, and that's kind of, I have no clue what happened to it, but that version, the version that I had that was more complete got deleted at some point for some reason. I'm not sure exactly what happened with it, but I have an earlier version of it to do that, because it was really annoying modifying the INI file even for me, because there's just like, no, I guess I could show it to you because I have it open, or I did have it open. What is this? This is in games. I don't want that. Let's see. Where are you? There. So, and this is what it looked like. I mean, like this for example, this is like what I'm talking about here. So this is ship ID ranges. So these are ID ranges for each class of ship. If we're gonna add a new ship in, you'd have to go in here and modify this. It gets even crazier when you get down towards planets, because I'm tracking a bunch of different things within one set here. This is for planet size check ranges and randoms and things for each planet class. So for 0 through 5. And it's just, you get all these comments and things here, but at some point this becomes just, random grouping of numbers that nobody will be able to decipher, period. And that's why I was making that tool for, to make this editing easier, and also to have it be able to edit the database as well, without having to have some sort of other tool somewhere to do it and have to go back and forth between them. So that's where we're at with that. And then eventually I said, you know what, this whole boost thing is stupid, partially because of this, and partially because I couldn't compile boost for 2015. There was some problem with the source files that broke the linker for 2015, and it wouldn't compile at all. Boost options, none of the boost stuff would. And I decided and I had problems with it before with stuff like this that was like was not easy to fix, but I could fix it, and that's how I even got boost working in the first place. Had to go through and search a bunch of stuff out and deal with a bunch of problems. Eventually got it to compile in 2013. 2015 just wasn't having it, wouldn't work at all, and nothing that anybody was suggesting was working whatsoever, even slightly, to remedy the problems. And they were pretty much the same problems I had before, kind of, but they were all related to the linker and how things were being connected through the project settings. So I decided, it's this thing, it's all this stuff in the INI file, it's just way too much of a hassle. We got this awesome database thing here, so let's use this instead. And that's what I started to work on for 0.6 after all of that. And then trying to integrate it into all the rest of the code. And then I eventually got so frustrated with that process that I stopped working on it for quite a while. In fact, I have no clue when the last time I worked on this was before recently, but from that point up until about 2.5 weeks ago, I was not working on this at all, pretty much. It's mostly working on stuff for the database and the lore as well. But then I decided, you know what, I want to get back into this and start dealing with this again, because I want to make some progress on this. And so I got into this code, looked at it, and it was like, oh, Jesus, I had to deal with this now. And I was thinking, you know what if we just rethink how we're going to do this, and I'll just make the pieces of it that would naturally come first in terms of how the game would actually create itself, if you will. So I kind of got down this outline in my head of how this would work. Obviously, you would have a universe class, because I'm thinking more in context of how the game should work rather than how it's working here. Here, all we're doing is we're just generating a bunch of planets with names, various stuff in them. Then we're just sending the player to them or to a station or something, and they're encountering things randomly and whatnot. The way that I'm envisioning it working now is more of how it will work in the actual released version, which is you're the player in a particular system, and at that system there are some planets, and from that system you have jump gates to go to other systems, and things are all interconnected within a actual structure. And so instead of like search for planet or whatever, you would have an option that would say local jump gates, and then you'd have a list of jump gates and the systems that they go to, and then you can go to that system, then come back to the system you're in, or continue on to other systems connected to that other system that you just jumped to. So kind of more of an interconnected web of systems rather than just a random scattering of planets. So with that in mind, I decided, well, let's just take that part, because it's pretty complicated, and there's all this other crap code here that can't compile because everything is broken and destroyed, and basically a pile of nuclear waste that has to be fixed. Thousands and thousands and thousands of lines of code have to be redone. I decided, this thing doesn't exist in here already, so let's just make it in some other project, and then we could bring it over. And that's how the current version of 0.6 started. Or rather, the current version of the code that will become 0.6 started. So I just wanted to take the code, and let's go and close this. Well, I should keep that open. We may need that for some other thing. So where are we? I think this is the one we want. So I just had that idea. Closes stuff too. So I had that idea to start with that. So we get this thing. It's basically, this was originally intended to be basically an updated proof of concepts project. So there was the SC test bed, which had a whole bunch of stuff in it that I'd used for testing various things. This is meant to be an upgraded version of it, and I was going to bring all that stuff over. And this is going to be one thing in it, because in that one, I had actually started this process, and for some reason, something in that project broke the linker entirely for custom namespaces. Just, it wouldn't work, period. No matter what you would do to try and set it up. No matter how correct the code was, it would always fail to link the functions in the implementation of the namespace with the externalization, or maybe that's the other way around, so the externalization is the implementation for a namespace, but with the namespace header, basically. And it just wouldn't work at all, and I couldn't figure out how to get it to work, and nobody that I asked for help could figure out what the hell was going on with it either, so I just decided, okay, I'm just going to get rid of this, and I actually went out and got VS 2017, and just built it over there, and then started working. So that's obviously something either with that project that's messed up, since that project was originally from, I think, 2011 was when I originally created that, and it's been converted from that to 2013, then to 2015, or maybe it's just, I don't know, something with the installation of 2015, who knows. In any case, it wasn't working, so moved that stuff over to here, and that's how we got this. So originally what was in here was just the universe class, the planetary system class, the planet and the planets class, as well as the asteroid belt, asteroid, moon, and station classes. There was nothing else in here. Oh, I guess, yeah, there was, well, they're not classes yet, but I did have some structs for weapons, ships, and equipment for testing the next phase of the thing, which was connecting the database to it. But initially, it was just those classes with a consts class, which is still here, that just had some random data in it to simulate stuff from the database. And the code would go through and just basically create a universe. So it would create the universe proper. In the universe, you would have a number of planetary systems in a vector. Those planetary systems would then spawn a random number of planets, and then those planets would spawn off a random number of belts, moons, and stations themselves. And that's like how far down the progression went. And once I got that working, I decided, okay, let's go ahead and make this a little more complex and plug in the database stuff. And then after that, I said, okay, now that we have the database in and I can confirm that it's working, the new code that I have, I confirm it's working. Now I want to do the big chunk of work for this, which is to implement the settings namespace, which I did and continue to do. And it's been actually kind of interesting going back through and looking at the old code and looking at how it could be further optimized and greatly reduced in the amount of code due to the decisions I'm making in the coding of the settings namespace. I'll show you what I mean by that. But first, let's go ahead and just kind of walk through this code here so you can kind of get a look at it. So this is the main, well, not the main class, but this is the class that will be called first for the game, even when we're over to actually making it simulate the game. So we create the universe first using this function. We set up the number of expansions and set it to 1 because it's the first expansion. There will be eventually a expansion timer, if you will, which will just count the number of turns. Eventually it will be a real-time thing in the released version of the game in 1.0. But for now it's just going to be turn-based because we're not in the engine yet. And then time since last expansion. Then we call these two methods here. So the methods functions, I'll use them interchangeably, just in case you're wondering. They basically mean the same thing. Block of code that's called and run outside of the context of the current place that you're at. So in other words, we're essentially leaving this context, which is just where we're at. So we're currently in the create universe function. So you can say we're within this function's context. We're leaving it to go to this function and run what's in here, and technically then we're in this context. It's a little more confusing for you coding noobs, or people that don't code at all. So we're calling this load system names, and what we're doing is we're actually getting data from the database, from the system names table, and feeding that into a vector, which we'll then use to randomly create planetary systems from. So we load all the names in using some stuff from the data classes. Whole database class. It's actually called the data system in this one, and I'll explain why there's only one in this one. Then we are just looping through using a awesome for each loop that I had no clue that was added in CPP 11, which made things really easy. Later on, I'll show you an example of that. So we're doing that. It's basically loading up a usysnames vector with strings that are system names. So then we call this create PL systems, so create planetary systems. We go through a for loop a random number of times, or not a random number, with a static number of times, with a setting set in the database. And for each time we go through, we're getting a different system name. So we're getting that from sysnames, the sysnames table here, or table, sysnames, usysnames vector. And then we're removing that name from the vector once we've used it, so we don't use it twice. This here will set the security rating for a system. Right now I just have it set up to go from 0.45 to 1. So it's basically medium to high. Well, actually low to high security. I think it's low. It might be the... No, I think 4.5 might actually be the bottom end of medium. Just for testing right now. It will go down to some other random value. I'll have to set up I think negative 1.0 will... Negative 1 will probably be the lowest you can go on the negative nullsec side. I don't know what that would really accomplish. Once you're in nullsec, it's all nullsec, so probably doesn't even matter. It could probably just be negative 0.5 or something, and that would be fine. And then we are setting the random element chosen up here from useSysNames to curSysName. So we're just saving that system name string to this string here. Then passing that to addSystem, which is a function down here. That will create a new planetary system and pass through the name, and which is what we're passing through with this curSysName, and this sec value. So then that will go there. Once that is done, once all that is done, we'll call setup systems, which is this function here. And this is where I was saying how it really helps this for each loop. So before I would have had to have done something like this. For int I1 equals 0, I is less than, it would be useSystems.size. And then we'd have to do that whole thing with that. Instead, now what we can do is we can just use this for each loop to go through each planetary system object in useSystems and then call the createPlanets function for each one of them. Now, you may have seen this and said, well, why is this here? Well, what I want to do is I don't want to have to set the element of this in useSystems. So what we do is we pass this as a reference, and so anything we do to plsys in this context now will actually automatically update into the vector. So instead of having to do something like this and then have at the end useSystems.at I1 equals plsys or equals whatever the name of it would have been. I guess it would have been plsys probably too. It would have created just a new instance of it in the iteration-based for loop, this kind of for loop. Instead of doing that and having all messiness, we just say, okay, for each planetary system plsys object in useSystems, do this, and then it'll automatically update it by reference. So this is in the planetary systems class. So what we do here is we just basically do the exact same thing, but we're creating planets instead of systems now. So we get a random number of planets from 1 to the max planet setting in settings. Going through another iterative for loop, we create a PL name, or create an empty string called PL name. And we do this because for planet names, we want to add a Roman numeral on the end of it based on the number of the planet. So instead of having individual names, now planets will have the same name as their system, but will have a Roman numeral on the end. So, for example, Sol, well, it wouldn't be Sol. Certain systems will have actually unique named planets. Those will be only the capital systems of the different empires. So you might have something like Alcott, which is the system that the story says that we start in. So Alcott 1, Alcott 2, Alcott 3, so on and so forth, indicating the planets in that system. Then we're setting that through this constructor using PL name and PL sec, which we're passing through. Which we're not passing through, which we are... Where are we setting PL sec? Are we setting it in universe? Or actually, no, it would be planetary system. No, we're in planet. It is universe. Yeah, we're in planetary system. Duh. Oh, right. We're actually using the constructor that has them both. There's two constructors. One that has this and one that has both. Here we go. So we're using this constructor here. So we're passing that through, passing to another constructor, pushing it back, and then doing this over and over again until we get the number of planets we want. Then we're going to generate planets. Now what this does is does the same kind of thing, the same for each loop here. But in this case, we're actually setting up the planet, so we're getting the setting the EKS values, generating or calculating or formulating the planet size, the population it has, and the defenses and shields it has as well. So that's what all of this is doing. Now, here's the first example of where the code really got shrunken down due to how I set up the settings function. Settings namespace, I mean. Let me kind of show you what this code looks like over in the old code. And it's not only because of the settings namespace of how it's set up, it's how I decided to code it this time. But the settings namespace stuff made it much easier to do, to shrink things down. So this is actually going to be in-game on this one, because in this version of the game class is the one doing that stuff. So, where are you? Alright, I haven't implemented the Empire creation stuff yet, so this isn't in there yet, but most everything else you see here is already implemented and changed. So, we start here. No, here. And all this is all just to do the planetary generation. All this right here. This is about 60 or so lines of code. This is also just considering the planet's EKS value in the conditional statements as well. That's about 60 lines of code. Over here now we have the same code, much smaller. It's about 20, I think. So line 73 to line 102, about 30. It's about half the amount of code. But here's the thing. If we were to code this version of it in the same way that we were coding the old code, this would actually be about 600 to 700 lines of code. The reason for that is for each individual planet size, you have certain things that happen. On this now, we're not just going by planet size. We're also going by, I guess we are going by planet size. UKS rating. Planet type setting. Okay. I've been working on so much stuff, it's kind of hard to remember exactly where things are at. This isn't the one I wanted to show you, explain as the penultimate example of how things have shrunken down, but this is a good example though. So we reduced it by about half, and it would be a little bit more actually if we didn't do it this way. It'd probably be about 70 to 80 lines of code. But as you can see, we really have shrunk it down quite a bit. And we have this iterative process here that's going on, where we're actually going through this setting class called planet type settings. And what this is allowing me to do is go through and instead of having this, like over here, where we have a bunch of these individual conditional blocks for each type, we can combine all of this into one single block using a for loop, and just pull stuff from that class's members from the data stored in it to process it, which is what we are doing. And then down here we get to this part where we settle that, and then we get the number of defenses. And then we go through and eventually I'll add that back in to actually add the defenses in. Right now this part's commented out for the moment because this stuff has to be modified to work now with the database. So, the other thing is, as you can see now, this was already compacted down from what it was over here. Over here, this is like 200 lines of code just for the defenses, broken out the way it is, like this. And I decided, no, how can we make this smaller? And I figured, well, it's only one line in the if statement, So why don't we just put them all stacked like this? And that's what I did. So it really shrunk it down. Same thing with this. And then once I got the plant type settings in, it's even easier. We just say, okay, we just do it like this now. We can just have 2 if statements and just loop through everything to get the information we need. So I took this is about 40, maybe 60, let me see. So 154 to 212. So yeah, it's about 60 lines of code down to like 10 or something. I'm not exactly sure how much this is, even. Very small. 141 to, yeah, so 11 lines of code. So it's a very, very good amount of compaction, if you will, going on there. So yeah, that creates the planet's information. Then once that's done, we're then calling a new function that's called set of planetary objects, set of planet objects. So this is in the planet class. And what it's doing is creating belts, moons, and stations. Now, asteroid belts is where I wanted to talk about, because this is where the way that the code works now, if it was coded the same way it was before, would be over, I think over 2,000 lines long, just because of all the extra stuff I put in now. That allows it to get much more detailed on how the asteroids are actually created. So we're creating the belts here. We're doing the same thing with Roman numerals. So planet name, asteroid belt, some Roman numeral, setting up the maximum size for it, and the number of asteroids that'll be in the belt. This function now calls this, and we're calling I'm not sure why we have it full, if not full. Else, this might be for loading purposes. I'm not entirely sure, but I think that this is for loading existing into the game, existing belts into the game. So we're pushing back a belt object into the belts vector of this class, and then we are setting the planetary security level of that belt as well, for that belt as well. So we're going to go to create asteroids now, which is where all the interesting stuff happens. So this code's actually a lot larger. We're actually calling 2 additional functions in the process of doing this. But it's pretty interesting in terms of how this works. So first thing, I want to make an observation to you that if you're coding and you're using SQLite, never, ever, ever use an OpenDB statement inside of a loop. Found this out the hard way. It should have been obvious, but the reason for this is because every time you call OpenDB, what it does is it loads the entire database SQLite file that you're indicating to open into memory. So every time we're calling this, we're actually loading the database, complete database, into active memory so that the rest of the programming for SQLite can access it and modify it and things. And if you call this within a for loop or a while loop, it'll just keep iterating over and over and over again, opening things, and you'll end up with a memory leak, which is what happened to me. This program usually only takes up about 5 megabytes of space when it's running now. Before, when I was running it, it was taking up to 500, sometimes 800 megabytes of space. So almost a gig of RAM, as opposed to 5 megabytes of RAM now. So yeah, that was like, I was seeing this like 500, 800 gigabytes of RAM, or megabytes of RAM being used, and I'm thinking, what in the hell is going on? And I just couldn't figure it out, and then eventually I was like, oh, wait a second. This is in a loop. We're calling this a bunch of times, we're not closing it. And the stack, I don't know what you call it, stack debugger or stack viewer, and the performance tools also helped me to figure out that might be what's going on, something with the SQLite code. So at first I thought it was because I was creating a whole bunch of resource instances that were getting filled with a whole bunch of crap. That added a little bit on there, about 100 megabytes of RAM into it, but that wasn't the entire thing, and that's how I stumbled into it being that. So what we're doing here is we're opening a instance of the database. Rather, we're taking an instance of the data system class and opening a reference to the database in it, so we can do stuff with it. And then we're going through here, and in this while loop, we're looking for, basically what we're doing is we're trying to fill the asteroid belt up to its capacity. So we are trying to fill it up to the maximum size of the belt, and we're also trying to, actually it's not even doing it, but it should be, making sure that we're not actually also overfilling it with too many asteroids. I'll have to add that in. It doesn't look like it's actually doing that right now. So that's something I'll need to make a to-do for. I'll put it up here. To-do. Okay. So while this belt isn't full, we're going to be processing this code and creating asteroids. The first thing we do is we get a couple of random values here, ore tier, which is going to be used to determine what the tier of the ore is. So I'll talk about that later. Roid size category, so if it's a large, small, or medium asteroid. And then ore stage, which is the stage of the ore, so 1, 2, or 3. And this is all done through obviously through a series of conditionals that will basically simulate a percentage chance of getting one of those various stages. And then next we come down here, and first thing we're doing now, instead of just going by whatever we're going through by before, some random values for something. Let's see. It's an A belt, so let's go look for A belt. So before we're just basically looking for the stages, going through and setting things up for the belts in a very kind of weird way. This is actually newer code that was trying to simulate what I'm doing now. The older code that this replaced was actually just we're just looking for only just filling up this here, and weren't really doing any processing on what types of ore would spawn and why they would spawn, or if they would spawn, and what kinds of sizes of asteroids they would spawn in, and whatever. This one, I wanted to make it way more granular. So I wanted to say, okay, we now have several new things we have to consider. We have the security rating. In higher security systems, we shouldn't be generating higher value ores in greater numbers, and when we do, they should be in smaller asteroids. We have ore tiers, which is something new. So we have to decide, okay, in this particular set of security rating blocks, we want to have these types of tiers of ore available at these rates. Then underneath that is the ore stages, which are dependent on which will be mostly dependent on the size of the asteroid. So we have down here if statements for the asteroid size categories, and then inside of that, depending on that, are the different percentages of chance for the ore tiers or ore stages, which are then all the data is then popped into this this method, this function down here. We go to get ore, which is another function that will actually go to the database and get the information, brings it back. We set it up in a temporary vector, pull some data from it to calculate the size, and then we go back up here and continue processing. So once we're done with that part, we then create the asteroid using that information, and then we clear the temp res vector because at that point the resources we have chosen for this particular asteroid don't apply. So we're going to go back through all this process and get another series of ore types to put into the next asteroid. And then we check our size to make sure that the asteroid belt size is not overflowed by the temp size. Temp size 3 is the running total of the asteroid belt's current size based on the asteroids that are in it. And that shouldn't go higher than AB size. Temp size 2 is the actual size of the individual asteroid being created. And temp size 1 is just there to store the value while it's being calculated on. If the asteroid belt size is less than what the temp size 3 is, then we're removing the last asteroid and rerunning this code until we get something that doesn't overflow the AB size value. Or if the temp size is less than or equal to AB size, we then look and say, okay, oh, here we go. Yeah, no, we do have this here. Never mind. I did not see that there. So we have a to-do, and the to-do has already been done. I am very efficient that way, apparently. So then we check and say, okay, so if the asteroid belt's size isn't overflowing, in other words, if the temp size is less than or equal to the AB size, then we look at the number of asteroids. If the number of asteroids equals the size of the vector, the asteroid vector, then we're going to say it's full. So we're not necessarily saying that the entire size of the belt has to equal the maximum size of it. So we could have asteroids in a combination where the total size of those asteroids is less than the maximum size the belt can handle. But if we're at the maximum of asteroids and we're either under or at the AB size value, then we're saying, okay, the asteroid belt is full. Otherwise, we're looking to see now if we don't have all the asteroids, but the belt size equals AB size, then we're saying this to true too. So either way it can happen. But I think more often than not this will happen rather than this, because having something equal exactly AB size is going to be pretty hard. But there would be some, maybe one or two out of every, I don't know, maybe 1,000 belts that would fall into this category. Now, if it's not any of those, then we don't do anything, and the belt just stays empty, and the bool stays as full, so we keep processing. The next thing we have here is just kind of, it's not really, doesn't matter in this because we're not displaying anything or drawing anything on the screen. It's just, because we should do it. Not because we have to or because it needs to happen, but because we should, because it's just, you shouldn't be spawning things on top of each other or intersecting with each other, even in text-based games, in my opinion. So that's what this does. We go through the entire asteroids vector, and we're looking for any asteroids that are on top of each other. So any asteroid that has an X, a Y, or a Z position that is the same as another asteroid. If we do, then we remove that asteroid and reset this to false, or just set it to false in case it was set to true. And then break the loop, obviously, because we don't need to go through here once we find that. And then keep going with the while loop until all these conditions are fulfilled, and then we end. And afterwards, we close the database. So there's now 3 new levels of conditions on top of what was already here before. If we were to code this out individually for each individual instance, and then in the same way we were doing before, we would have literally a couple thousand lines of code, because you have 60 or so lines of code for the initial version, which is just the asteroid size. Or I think it was just based on ore tier or something. I'm not really sure how it was before, but it was 60 at one level of conditions. And that level of conditions has to apply for each level, each higher level of condition. And then those conditions, along with the first ones, then apply to each higher level of condition and so on and so forth. So it's basically like a conditional tree where each condition, each of the higher level conditions has to contain the lower ones. So we would end up having around 2,000 lines of code. And the way that I made the settings class allows us to do it much more simply like this. So let's go ahead and talk about the settings class, and we'll talk about the setting namespace, and we'll talk about the database stuff. So I wanted to figure out a way that we could easily do this, because there's several ways to go about doing the settings. You could either just do what basically what boost is, and essentially similar to this, and you just go through and say, okay, here's all these different settings, we want to get the values for them, and somehow get them from the database that way. Or you can do what I've done here, which is to make it so that we can have kind of a hybrid of that plus something smarter for things that have to be smarter just because of how the settings should be distributed throughout the game. So we have this map that called raw settings that is a string map. So the key is a string and the value is a string. Which works because in the database you can't set multiple types to a field. So in the database you would have had a cross-reference table between setting and then the setting values, or we would have had some sort of weird thing where we had multiple fields where we had like a string setting, int setting, float setting, something like that. And both those I looked at and said, I don't want to do that because that's just stupid. So I made up both strings, which works out pretty well actually, because you can pretty much cast a string to anything. It's just a matter of making sure that you have the right formatting in the database. So since we have this map, it was pretty simple just to call in all the things and set up a map with them, and then to use that map to get the values by using the setting name as the key. Now, granted, doing it this way means that you can't add your own settings, which I think is fine. I think that's how it should be, because you add your own setting. Well, what's that setting supposed to do? How's the game supposed to process that setting? Sure, it can see your setting key and your setting value, but what's it supposed to do with that? You know, because there's no way you can add the code to do that unless there's also some way to add custom coding through the database, which that's a whole other box of worms. Some games do it, like Ragnarok Online has the ability to do that, to put item scripting within the database. I wasn't going to do that for this because that was going to be a nightmare to try and figure out. So instead, I decided, okay, whatever settings are in the database, those are the settings, no new settings. The values, though, sure, change them however you want to within reason, and as long as you change other values that depend on those ones you're changing. And I'll give an example of that in a bit. So we have these settings here, which are by no means all of them. They're just the settings that don't really apply to anything other than themselves. So there's nothing that depends on the universe expansion rate, for example, for setting some other setting. So that's a singular setting, a singleton setting. On the other hand, you have things like difficulty settings, which are a group of settings that will set a value of a particular type of setting based on the difficulty the player selects. So for that, you could do it this way, but if you did it that way, then you'd have something that's really huge, because now you have a difficulty. You have one setting for each difficulty for just that one setting. So player shield damage for all the settings for easy, moderate, hard, realistic, and extreme, or extreme and realistic, either way. I'm not sure what the order of it is anymore. You would have a setting listed here for player shield damage. So that's 5 settings for one difficulty setting. And you have to encapsulate that here, and there's about 7 or 8 different actual groups of difficulty settings. So that's easily like 40 to 70 different settings just from that. And I've said to myself, I'm not going to do that either, because then we just have a bunch of spam in here, and it's really annoying for me to code it, because now we got all this stuff we have to handle that way. Instead, I said, okay, what we'll do is we'll create a class for difficulty settings, and then from here I extended out to other types of settings. And in difficulty settings, let me go to the header file. It's easier to see it that way. And in this class, we have obviously a bunch of functions to handle setting the different values. And we also have string placeholders for these values, and functions to process the data from the database. So, first thing that happens is that we call this function called load difficulty settings, load diff settings. We go through and make sure that load diff settings is set up properly. So for every game difficulty, so for every game diffs, every element of game diffs, which is a vector that stores a string vector that stores the output from this function here, get difficulties, and it loops through there and creates a instance of game diff settings for each difficulty. So easy, moderate, hard, extreme, and realistic all have their individual instances of this class. And then we say, okay, for each one of these newly created classes, we're looping through them now, we want to get each map element from raw settings. And we want to be able to look at this and say, okay, what does this belong to? Is this an easy setting? Is this a hard setting? The only way to do that is to turn it to a string, because you can't search partial keys. That's one of the downsides to maps. But it's one that I have to deal with because it's a lot easier to do this with maps than with a vector of vectors, for example. It's because the way a map works is you look for the key. It has to be the full key, otherwise it will say that it's not there. So you can't say, like for example, you can't say you have to say planet types. You can't just say planet_t or something. It has to be the explicit name of the key. And there is no way to partially search them at all. .find is basically the same as .and for maps. The only difference is that .find does not have null checking. So in other words, null checking means that .at, if you look up a setting whose key is not present in the map, then it throws a... oh, crap. Excuse me. Then it throws an exception. An out-of-range exception, which we're handling down here. So like, for example, if I had typed this and say planet pop rand 1 me, so I typed it like this, and I ran it, the game would crash at this line because an exception would be thrown because the map would say that this doesn't exist in it because I typed it there. So I had to figure out a way to do that, because that was the crux of how this had to happen, because you have to look for things that have a suffix of easy or whatever the difficulty is on them. And so I just tried to figure out a way to do it, and came to the information that allowed me to reach the conclusion that it wasn't possible with maps. So I decided, okay, I know we can do it with a string, so we'll just cast the key to a string, which is what this does. Store it in some temporary variable, and then do a find on that. So that's what this does. If temp string, so if the key .find contains diff.getDiff, so we're getting the difficulty from the class that we set up. And then doesn't equal string no pos. So if it doesn't, essentially, if find does not reach the end of the string, then it exists. If it does, then it doesn't. Then that doesn't exist in that string. So, for example, if we're looking, let's say, for easy, since that's up here. So let's say that I'm looking for CXPP base value easy. So what we could do, what this essentially says is that we have this key, and we want to see if that key is from easy or hard or medium. Let's say we're looking for easy. So we get the key, which is this. So again, the key in this case is going to be the CXPP base val easy. That's the key that's stored here. And we're looking at the string to find easy, to see if easy exists anywhere in that string. Since it does, we go to this, which is diff setting, diff set settings. This is a member of the game diff settings, gdiff settings class, or yeah, game diff settings class. And we are passing through the map key and the map value, both as strings, down to here. Or no, not that one. Set setting. Down to, where are you? Set setting, set setting, set setting. Set setting. So what we're doing now is we're taking this key and we're looking now and seeing if we have the first part of it. So, but we're looking at this, we're actually looking for the actual name of the key, not for some dynamic thing, but actual hard-coded version of the key without the difficulty on it, so that any difficulty version of this key can be found. So this could be easy, it could be hard, it could be moderate, it could be realistic, it could be anything. Any difficulty can be falling into this function and be picked up. And so if the key is CXPP base val, then we are setting this string value from this class to here. Now, after that's all done, we are calling the other one that you saw here, this one. And we are setting for the, so we're looping through this again, and we're finding the actual setting category, or setting instance now of the setting, the difficulty setting the player's chosen. So again, we're saying that it's easy. So this will loop through, and the first element's going to be the easy one. So if diff.getDiff equals sGame difficulty, which stores the difficulty the player's chosen, then we get the values from those difficulties and set them into the settings namespace variables for those. Now, I've done this much differently on the other ones, so it's all internalized to it, nothing in the settings class specifically for them. So again, planetary settings, same process. We are calling the load planet settings, doing the same thing, setting up the vector, going through the vector and looking for the, in this case, the type, based on the type. So type 0, type underscore 0, type underscore 1, type underscore 2, 3, and 4, and 5. And we're trying to find the different planet settings for those types. And then we are passing that to this process planet settings function, and we're actually returning to reset the reference which we have here from this class, because we're changing things in this that are related to this specific instance of game planet type settings. So in this one, we are doing the same thing. We're passing it as a passing the planet settings reference, or passing the key and the value as strings. And we're doing basically the same thing, except on this one, we are then calling the set function from within the class reference itself, and then we are casting it to the particular type that we need as we're passing it through that. Another way I've discovered or worked out to reduce the amount of code that we need to use is by taking a function and essentially combining the high and the low value setting into one function, and differentiating between the max and the min value using a bool, like you see here. So this is setting the minimum value for the EKS range. So we're passing a false here. The bool for this is b is max. So if it's true, that means it's a max value. If not, it's a min value. Based on that, we're varying how we're setting the value, where we're setting it to. So same thing here. We're looking for the particular key from the database, and then we're using these functions to set it to ranges or individual settings that are in the class instance. So we'll go to this. As you can see, so b is max, float val. If b is max, set it for the f high of that range. If not, set it to the f low for that range. And we do that for all of them, pretty much. And that's how the other ones also function, the other classes that we have in the namespace. So this is gonna be kind of a long namespace once everything is in here, but at the same time, it's gonna be very easy to work with.